Here we're told, without using a calculator, determine two possible values of theta between 0 degrees and 360 degrees that satisfy the equation below. And the equation that we're given is cosecant of theta is equal to minus root 2. So recall that cosecant of theta is the reciprocal of sine theta, the reciprocal of the sine ratio. So we're going to rewrite cosecant of theta as 1 over sine theta, and that's equal to minus root 2. If we take the reciprocal of both sides, we get that sine of theta is equal to minus 1 over root 2. Now, let's think about this. Here we're asked to do this without using a calculator, so I can't just take the inverse sine of both sides, or the arc sine of both sides, and say that theta is equal to whatever my value spits out, because I'm not supposed to have a calculator for this problem. So what I can do, though, is I can refer back to special triangles. I can think about where this is on the unit circle, or what quadrant theta's in. So theta is in, remember that the sine ratio, if we use the cast rule, the sine ratio is positive both in the first and the second quadrant. So that means that our angle is either in the third quadrant or the fourth quadrant. So let's think about what our reference angle is now. We know that the ratio, when the sine theta is equal to minus 1 over, or let's just say sine theta is 1 over root 2, we get this ratio in a special triangle, and that's a 45, 45, 90 triangle. So if this were 45 degrees, and this were 45 degrees, this is 90, we would have the ratio of 1 to 1. Remember that the sides in this triangle appear in the ratio of 1 to 1 to root 2. So that means that the reference angle is 45 degrees. Now, since 45 degrees is our reference angle, and our angle is either in the third quadrant or in the fourth quadrant, theta could be equal to 180 degrees plus 45 degrees, which is equal to 225 degrees, or theta is equal to 360 minus 45 degrees. And 360 degrees minus 45 degrees is 315 degrees. So the two possible values for theta are 225 degrees and 315 degrees.